Welcome back to my YouTube channel, and I'm going to move on to finding how to find for the coefficient of a naught in the Fourier series. So now let's move on. Finding for the coefficient of a naught. How do we find for the coefficient of a naught? For us to find for the coefficient a naught, we have to cancel out a n and b n. But how do we do that? Now I actually wonder about that. But there is an actual trick here. What if we integrate both sides with respect to the x? Then we can actually cancel this out, since the integration of cos nx dx from 0 to 2 pi is 0, and the integration of sin nx dx from 0 to 2 pi is 0. So therefore we should just integrate both sides from 0 to 2 pi, and that actually makes sense. So we do that for both sides. We have the integration from 2 pi to 0 of f of x dx, of f of x dx, and we also have plus equal to, now this a naught, we have the integral from 2 pi to 0 of a naught over 2, then we have this as well, dx. Also have plus the integral from 2 pi to 0 of a n cos nx dx. We also have plus the integral from 2 pi to 0 of bn sin nx dx. So what we just do now, you might wonder that, okay, what do this summation sign do? The summation sign does not actually go anywhere. It's just that integration is, it acts more of like a summation of everything all together, just that we are giving our part from 0 to 2 pi. So now that we have gotten this, so we can bring out our constant outside of the integration, since we are integrating with respect to x. So therefore this is going to give us um, a naught over 2. Then we have our integration of the x. We have 2 pi and 0. That means what is going to be here. Then we have plus, we can bring our a n out. Integration from 0 to 2 pi cos nx, the x, plus bn, integration from 0 to 2 pi sin nx dx. In that particular scenario. So now this is going to be integrated. It's going to work. But now we look at this and we look down at this. We already know that it's 0. You see, we could have gone through an entire integration of this and end up finding out that it's 0. But based on the fact that we know our useful integrals here, we can just be able to assume that this is 0 and that is 0. You can go through the process of finding for the integral yourself. You're going to end up finding out that it is 0. So now for this, we are going to be having a naught over 2. We have our a naught over 2. Integration here is going to give us x, and we have it from 2 pi to 0. Now this now is equals to 0. This here is equals to 0. Those two are equals to 0. So we can just continue this. We are going to have our a naught over 2 into bracket. We have 2 pi minus 0. That is 2 pi here and 0. So here the 2 cancel 2, and we are going to have a naught over 2 into bracket 2 pi is after the 0. So 2 can cancel 2. We have this as, let's not forget what we have here, which is the integral from 2 pi to 0 of f of x. The x is equals to this, which is equals to pi times a naught. So now since that we have this, what we are actually looking for is a naught. So we just make a naught the subject of the formula. So therefore, if we make a naught subject of the formula, we have 1 over pi integral from 0 to 2 pi f of x dx is equal to a naught. Is equal to a naught, and so that is how they got the formula. It's just in this other manner, where we have a naught is equal to 1 over pi integral from 0 to 2 pi f of x, the x, and that is how to get our coefficient of a naught. And our 0 to 2 pi is not specifically based on 0 to 2 pi. You might be given a question of minus pi to pi, and that is also an integral from 0 to 2 pi, because the period is 2 pi, but it's just from minus pi to pi. But the main point is that the period is from 0 to 2 pi, but this is going to be the formula over here. Thank you very much.